All right, so yeah, we are going to be talking about Drama Fever, which is kind of an internet TV platform that uses a bunch of technologies you may have heard of.
Right, so...
oh, and I like the part where the remote chooses to not work, even though it worked in test. Pete can stand there. There we go.
Yeah, so to begin, let's talk a little bit about ourselves. My name is Peter Shannon. I work at Drama Fever as an operations engineer. And I'm also an organizer for DevOps Days Philadelphia.
Yep, and I'm Bridget Kremhout, and I currently work at Pivotal. Until 2 months ago, I was also on the ops team at Drama Fever. So this is my last chance to give this case study talk and give it with Pete, which is pretty exciting. I also do DevOps Days, both Minneapolis and as a global co-organizer. And I podcast with Matt Stratton and Trevor Haas at Arrested DevOps.
So DramaFever.com is a internet TV service, right? Primarily international dramas. We own 3 properties. This is the oldest and bears the name of the company.
And this one is, I like to describe it as, it's kind of like Netflix if Netflix were much smaller and mostly Korean soap opera and ran Docker in production. So, a lot like Netflix, only maybe not so much.
Exactly, yeah. And we also subtitle in Spanish and Portuguese.
In English.
Yeah, in English, true. Second property, which is a partnership with AMC, is DocClub.com, which is documentaries. Mm-hmm. That was started in fall of 2014. And lastly, the newest addition is Shudder.com, which is horror and has had a really great reception so far and just started in summer of 2015.
Yeah, isn't Frodo a big fan?
Frodo is in fact a big fan. He's tweeted about us.
And something else that's kind of cool about those 3 sites is that I still say that, it's been 2 months. Drama Fever actually uses the same Docker image to power all 3 sites, just injects environment variables. So.
Cool. So this slide talks a little bit about our content. You'll see a bunch of flags at the top. This is where most of our content comes from for Drama Fever. Some of these numbers could potentially be outdated, let's say they're not. And you'll see that behind the red overlay here is how our traffic variance swings throughout the day. So what that would tell you is most of our customer base is here in North America and South America. Because obviously if we were more spread out, it would be more of like a hill rather than a spike. And we see peak loads of 10x, 20x throughout the day.
Yep. And so when we auto scale up and down pretty aggressively in AWS, cost control amongst other things. And when we scale down, we don't scale down to nothing. That's the funny thing. It's like people watch fewer K-dramas when they're sleeping, but not no K-dramas for reasons that are not entirely clear to us.
Yeah, someone is always watching TV.
And we do we're not going to be talking about the video stuff specifically, so sorry if you came for that, because the transcoding pipeline stuff, not entirely Dockerized. I think that's in progress.
Right.
And the streaming video delivery part is going from the edge from a CDN. So.
Right. Yeah, this is mostly going to be about how we built a platform and the case study surrounding it. Mm-hmm. So we'll start off with our software stack. The original app is in Django. We use Celery SQS for async tasks. And all of our microservices are written in Go, such as the trend, and it's a really fun language to write stuff in. And we consume a lot of AWS services, RDS, DynamoDB, unfortunately, and Elasticsearch.
Yeah,
or Elasticache, sorry. We do use Elasticsearch as well.
I think that this picture you chose because that one in the middle is DynamoDB.
Yeah.
So why we went to Docker, and this is something that I kind of feel like maybe we should surprise Tim Gross and pull him up on stage. He's like, no, and make him tell the story. But it was mid 2013, and it made a lot of sense to go to something that was both more consistent for development, but also led to more repeatable deployments. Because if you're just checking out code from GitHub and hoping that all goes well, it doesn't always come out the way you expect every single time.
and now we have to go back. You need one of those like.
So back in time, previously on Drama Fever.
Yeah. So, you know, like most places, we used Vagrant before using Docker. Vagrant has its own issues, especially when using Chef Solo provisioner, such as when people update your Chef repository, you have to pull that back down, you have to rebuild your Vagrant images, that takes a lot of time.
Or not rebuild your Vagrant images,
Yeah,
which is way faster.
Not do it.
But then leads to being out of sync.
Right. So, and another area of contention is dependency management and the fact that that can be a real pain and is something that Docker solves, right?
And it took way too long, so people never wanted to rebuild their Vagrant boxes until nothing was right and everything was sadness.
And so now, with Docker images, all the dependencies are baked in. They come up really fast. You can pull down the Docker images from your local registry or wherever your registry is, and it increases development cycles. And the same image that you're running on your laptop can be the same image that's being run in production.
And I think it's probably important to put a little bit of time into talking about how this isn't just wait, if we start running in Docker in production, does that mean that the devs are doing a Docker build on their laptops and then YOLOing that out into production? Like, that could be dangerous, maybe terrifying, I don't know. So let's go into a little bit of detail about that.
So locally we use Docker Toolbox, but to Bridget's point, we don't allow anyone to push to our Docker registry. We use Jenkins as a gatekeeper. But everyone has the ability to pull down any of the images, and that includes pulling down the production images. Right now we're using Docker Toolbox. Docker Toolbox comes with Docker Machine, Docker Swarm, Docker Compose, and Docker. I don't know, there's probably a whole bunch of other stuff in there that I haven't even played with yet. Previously we were using boot to Docker, which worked fine enough. For those of you who haven't used Docker Machine yet or in the process of migrating over, it's essentially the same thing. It just gives you the ability to have more VMs, right? So you're not just stuck using the one that boot to Docker gives you.
Yeah. So I think a lot of people think when you're talking about Docker in production that it'll be super easy because, you just Docker run. Like, that's all it is, right? That's simple. But it's not really that simple because even with Docker and even with things that are, coming up in the Docker ecosystem, there is a lot more to do than just run a container because, well, what are you going to run it on? Probably something. If we ask the Joint folks, they'll say bare metal. But, you've got to run it somewhere. So. Yeah,
and I feel like this is a good representation for a lot of technologies out there because, you go to a blog post and they're like, whoa, here's how to set up, Kubernetes, here's how to use Docker, do it in Vagrant, and, it's all perfect. But, and that's great, and that's just like, buying a Lego box and putting it together. But then when you actually go to put it in production, things sort of change, right? Like, now you have this service in your request path. There's potential for failure. You need to understand those cases of failure. You need to understand how to fix them.
Ocean currents, killer whales. You got a lot of things you need to consider. One particular thing you want to think about is what are you going to use for a registry? Okay. Docker Hub now has private registries. They did not when Drama Fever started using Docker in production, so we obviously had to roll our own in that case. At reInvent, Amazon announced, hey, look, Amazon's doing a container registry now. That's super. I kind of feel like it's an Oprah thing, and you get a registry, and you get a registry. And this is fine, except that you need to think about, and this is back to the, who controls your availability. Cheslak was talking about who controls your security in his talk. It's like, who controls your availability? I got to tell you, the number of times that we got paged because Docker Hub was down, because we were just pulling the registry container from it, is more than the number of times we got paged because our registry went down. So let's talk a little bit about the registry and you should definitely go check these slides will be online after, and you should definitely check out the blog post that Tim, I'm going to pick on Tim some more, that Tim wrote. I'm going into some detail about the host local registry, just because even if you're doing this all on Amazon and you're like, oh, it'll be easy, I'll just use Amazon's registry. If you do it yourself on S3, it is cheaper, so.
Yeah, and this in particular is one of the the things that people seem to be the most interested in when we talk about how we have our Docker set up. Because, I mean, you know, it says it on the slide, but to be clear, like we run a local registry on every single instance. When an instance comes up, when Docker starts, upstart says, hey, Docker started, spin up this registry, right? That registry then uses S3 as its backend store. And this is really great because, you know, we get HA, right out of the box because of that. And we don't really need to worry about security because it's on localhost.
And the reason that Paul and Tim went this way is because when auto-scaling up, you know, I don't know, 20 or so instances, the single point of failure registry that they originally tried, which is, you know, what the docs at the time said, try this, fell over. So instead of, you know, trying to build that out to be more distributed, they just went completely distributed.
Yeah,
Which works pretty well.
And there's even more reason nowadays to do this, I would say, because with the new registry out that's written in Go, it's a lot quicker and it's built into Docker as of, I think, 1.7 or 1.6. And these are some of the tricks that we had to do in order to get this to work. So you have to edit your Docker configuration. The insecure registry is the key one in there. And I would say the storage driver is key too. Don't use device mapper.
Oh yeah, Cheslek's looking at us and thinking, wait, you want to be insecure? Okay, seriously, if somebody is on your instance, you know, man-in-the-middling you there, you have more things to worry about than this. But yeah,
they can't push from there.
The storage driver thing, we did, earlier versions of this talk had many, you know, much hating on device mapper, which I firmly maintain is sadness as a service. But you don't have to use it. Just use AUFS or Btrfs or overlay or whatever. Just don't use device mapper. It's terrible.
Yeah, and the other interesting trick, and this took me for a loop, was assigning an A record to whatever you were considering your local host for your registry.
Oh yeah, that's pretty important because especially with the new version of the registry, because now the URL of like what your registry is baked in to the images, which it wasn't before.
Right.
So including the port number for reasons.
And then we use Upstart. So Upstart is how we manage all of our services, how they come up when the instance comes up. And this is sort of a snippet of what the registry looks like, what we're passing it. So we pass it the volume for the registry comp, so we can use the config file, and the rest is pretty self-explanatory.
And again, the slides will be online later, so don't feel like, if you want to do any of the stuff that you have to write it down or that we're going through it too fast. We kind of just want to walk through it to show you that the stuff is possible. Right.
And again, we use S3 as our backend store, so you have to provide some sort of credentials. We recommend making a IAM user for this and then locking it down in all possible ways except the ways that you need it to work.
And the reason that that's highlighted is because we actually use a different config file for Jenkins. So Jenkins is the only thing that has the IAM credentials to push to that bucket. We don't want to accidentally be like, Docker build, Docker push, like, after the reception, drunk tonight. I mean, I don't have those credentials anymore, but you do, so.
I won't be anywhere near my laptop, hopefully.
And this is, and you might be thinking like, okay, that's great on your servers, but what about local? Hey, there's no reason that you can't run the registry container on your laptop. It's like, run the registry container. With the previous slide, we were showing how for the Mac, because it was after, I think, 1.3, they switched it so you had to use the host-only network. Yeah. So you can't use 127.0.0.1, but just override your DNS entry in your Etsy host, and you're golden. Oh yeah, and if you're using the S3 backing thing, be aware that S3 cares a lot about clock sync for reasons. And so if you let your laptop go to sleep and then you wake it back up, everything is bad.
Yeah, and this will happen on any VM, so Docker machine or boot to Docker will have the same problem. Jenkins. So Jenkins, as I said earlier, is what we use as our gatekeeper. We also use Jenkins to build images and try and get some form of continuous development, right? So when pushes are made to GitHub, new images are built and tested.
And I think the valuable thing to keep in mind here too is that, again, we were worried before about how somebody just does a Docker build and you're like, great, I have this Docker image. Do I really want to run that? All of that, so many of the public images out there on Docker Hub are insecure. I'm like, that's super. Would you ever take one of those and run it? No. You want to control the provenance of your images. You want to control your pipeline. So If you have your images being built by a consistent, in a consistent fashion by Jenkins, you have a little bit more understanding of what's in them.
Yeah, and in that same thought, I would say if you are using a public image, push it to your own registry and start managing it from there.
We are getting way off topic here,
Yep.
but I should mention that Docker Notary is coming along and looks pretty cool. But again, then you have to sign or have somebody sign and then know what you're getting.
Yeah, which would be very useful for a problem that we'll talk about in a little bit. So we have a weekly base build. The base build's really great because we can package in all our dependencies and do our apt-gets and basically have these layers in Docker that are ready to go so that when code is pushed, that is just the actual application itself, that build process for the image is lightning fast, right? Because if we have to from Ubuntu and apt-get and do all those things on every single push, to get, it's just not, it wouldn't work.
That's continuous frustration.
Right, it's continuous frustration.
I think it's the technical term for that. Oh yeah, and so then this is an example of, and this is the monolithic, Python Django app, but this is an example of one of the builds. It goes through, does a build, just calling it by the git SHA, runs tests. If the tests pass, tag it as dev and push it into our, registry.
Yeah, and it's really nice, that we can do it this way because having the option to tag it, right? So it's like we don't have to complete this transaction if the test fails. Yes, containers building containers. People will. There are lots of blog posts about this. People will talk about this, but these are actually the way we've done this is pretty neat. So I actually want to talk about the second one first, the Go microservices and Android APK, because I think this is a really nice way for anyone or a company who doesn't currently have Docker in their request path or is afraid of putting Docker in their request path, but is interested in using it in production. So we've actually used Docker to build APKs. You can use Docker to build jars. You can use Docker to build pretty much any type of binary that you need. And the way you do this is you package all your dependencies in, and then you end up mounting the directory that has your code, and potentially another directory if you want the binary to go there. And then your command is actually whatever you need to build. So if it's make build or something like that, and because the volume command is mounting the host instance, when you're done running that command, lo and behold, you have a binary dropped on your host. So we do this in Jenkins to build our APKs for Android, and it's pretty neat.
Yeah, and it also makes it possible for the Go microservices.
Right.
If you can go with statically linked binaries, I mean, at this point you have to make some, hard life choices, like how attached are you to libc? But assuming that you can run something without too many external dependencies, it makes a lot of sense to build and then ship something much, much, much smaller.
Right. Yeah, so this example right here is a Go microservice that the container itself is 10 megabytes.
That Tim wrote.
Yeah, and it uses the Scratch. It uses the Scratch image down at the bottom that's 0 bytes. But it's a little tricky to do this. This microservice in particular interacts with DynamoDB, and that's over HTTP. So you don't have to use a database driver. I haven't had much success trying to get a database driver statically linked. So we end up with images that are a lot closer to 400, 500 megabytes.
Yeah, depending.
And that's also because Ubuntu.
And we care about the size of the image because when we're auto scaling up, we're doing a Docker pull. We'll show you what that looks like. Oh yeah, cleanup. So even though we auto scale up and down, and you think, okay, you have ephemeral infrastructure, right? So you never have to worry about your disks filling up because you're just going to terminate the instances before you have to care. Not really, because things like your Jenkins server and dev and QA boxes do stick around. And so then you have some stuff, and this is not actually as yellow as it looks because of Docker's defaults. Of course, if they change the defaults, we're totally screwed.
Yeah, I mean,
it's not going to remove running containers.
Yeah,
now.
the top one in particular kind of scares me, and it does totally work. Yeah, I mean, you'll find it on Stack Overflow.
You know it's safe.
So you know it works.
Plus it's a conference level.
But like,
you know it's okay.
what Docker remove does if you don't pass it the -f flag is it'll remove any of the containers that aren't running. But like, if they ever decide to change that,
yeah, that would be a problem.
yeah, you don't want to have this running in a cron job like we do.
And then cleaning up images, like on Jenkins, cleaning up the images from all the failed builds is kind of useful.
Yeah.
Otherwise, your Docker rip might fill up, and that leads to bad things. We'll talk about that in a minute.
Yes, Docker and storage problems. This is what I was talking about earlier as far as Notary and having the signed images. This was a really interesting problem that we had. So Docker lives on a file system, right? And when you pull down an image, that image has to go somewhere. So if you're running out of disk space while doing a Docker pull, you would expect it to fail, right? You'd expect some sort of message saying, I couldn't finish this operation. Done deal. You go on the instance and you sort it out. We had one case, and this is with Docker 131, where the operation completed, everything seemed perfectly normal. In fact, the application actually started up. It's just that it didn't work. And we were really, really confused. And it took us over an hour, working with QA because, they're like, we tested this thing. I swear it works. And eventually, I got into the image. I bin bashed into the image, and I started poking around, and everything was where it seemed to be. But then I noticed that the file sizes looked really odd. And so I started catting some of the files. They were all empty. I mean, at least a good handful of them were empty. And so
it copied in file metadata, and then because the disk filled up, did not actually bring the contents. Oops.
It's only happened once, but it can happen, right? So this is where the signing would have been great, because we would have known ahead of time that this was not a valid image. It would have saved us a lot of effort. Yeah, import error, no module. We're
where did the module go?
Pretty sure it's there.
Can we blame Device Mapper for this one?
Yeah, let's do that.
Yeah, let's blame it. It's probably fine. Oh yeah, the deploys. So I feel like there's a lot of stuff that's been happening in all of the how you orchestrate and deploy this stuff that is way fancier than what Drama Fever is doing, and that's probably fine. This stuff actually works. I mean, as much as when Brandon was talking about you can start out using Fabric, and I'm like, you could still be using Fabric, it does work. And it's just kind of take the image that you've built on Jenkins, tag it for staging, and this would be the image that's been QA'd, tag it for staging, smoke test it, if it works, tag it for prod, and then the script goes through and pulls instances out of the ELB and does the Docker pull and does the upstart, restart, and puts them back in the ELB. And this can happen, I wouldn't say unattended, but without a great deal of manual intervention.
Yeah, I mean, for what we do, it works really great. And yeah, Brandon from CoreOS was talking about using Fabric as sort of this common way that people do it. But then he jumped right up to Kubernetes, and we're just like, okay, that's kind of unfair. You just went all the way up here. But I mean,
easy, right? You just type some more.
Yeah. So we'll talk about how we use Docker and Chef together. They can be friends. They don't have to be competing services. When at ChefConf, a lot of the sales and marketing individuals were very interested in the opinion of, these things can work together. They don't have to be competing services. And
pretty much the reason for that was because when we mentioned we use the same, when we mentioned Drama Fever uses the same, Docker image for these disparate sites. I mean, fortunately, this isn't the sort of multi-tenant thing where they're bringing their own and they're logging in, but it does mean that we have there's a great deal of config file, shall we say, drift. If you start out, as Drama Fever did, with just user data and injecting user data into autoscaling groups when starting to launch the instances.
I'm going to move a little quicker here. So yes. So we had to wrangle all this spaghetti config. So when I started back in November, this is the kind of thing that we would see. So if you would have run head on one of our user data files, this is the sort of stuff you would see. We basically would have catted all of our config into
the upstart.
Through the user data onto the machine, and like it totally works, right? And if you only have a few different machines,
or a few different kinds of auto-scaling groups.
Yeah, like you can get away with this. This will not scale. It's very hard to manage.
And then with 3 sites and then a proliferation of microservices, it's like no.
Right. So what the user data file ended up looking like in the end was this, right? Because we're running Chef now.
Yeah. So.
And the only thing that was templated is the role name and the environment.
Yep. And this is. We don't need to go into great detail about any of this, but just showing you that it is the upstart does a Docker pull, and then it does a Docker run, puts the environment in, puts the config file, the desired config file in, and uses the start command and pulls the stuff off of our local container for the registry and does the start command that you expect.
Yeah, and as far as templates go, I mean, anyone can look at this and say, oh, I can make a template out of this. And so we did. In fact, we made a lightweight resource provider. This is the template that's part of it. Just goes through the attributes we give it and drops them in the template. Here's the second half of it. And these are the attributes that we assign to the lightweight resource provider.
After a little while, and the reason that Pete wrote the first version of the lightweight resource provider, and then he ended up iterating and writing a second one pretty quickly when we realized that we made a lot of assumptions at first about what should be the default. I got news for you. Nothing should ever be the default.
Yeah, we tried to be very opinionated. It was like, we're like, things will never change from this, and then of course they changed.
Or like, the default will always be, and it's like, except for in this case, in this case, in this case.
And then you end up with if else, and you're like, ah. So it ended up looking something like this, where we were able to, it may look messy, but I swear it's really great. And so the things that change in here are the service and the environment. And we ended up using Packer to build our AMIs along with Chef.
And that was mostly just because we didn't want to. How did Tim put it? We've kind of set up Chef to be a sort of terrible init system, in that if the initial Chef client run would fail, if for whatever reason, again, we're auto-scaling up pretty frequently, if for whatever reason hosted Chef would not answer at that very moment, we would end up with an instance that didn't get the configs that it needed.
So these slides will all be posted, so we'll sort of gloss over some of this config here, since I want to have some time for questions. This is sort of the step for building our AMI using Chef. And you can see we have to provide it a number of variables, depending. You have to provide it the 509 for instance, Amazon instance. You don't have to do that if you're doing an EBS-backed AMI.
Oh yeah, and this one, I like keeping this slide in here because on Packer.io, Mitchell, Seth Vargo, they're all wonderful people, but they seem to think it's a great idea to say the right default permissions are all the permissions. And while yes, Packer will work super if you give it all the permissions to terminate everything that you want in your production infrastructure, you possibly maybe don't want to.
Yeah, I mean it's the path of least resistance, but if you want to make sure that you're not giving whatever automation tool you choose to use, like keys to terminating all of your instances.
Why ever not? Yeah, these are the minimal permissions Packer actually needs to work.
Yeah.
So.
And this is what our architecture ended up looking like once we had the whole system working. So, a dev, someone would push to GitHub. Jenkins would, periodically poll GitHub, and updates would go out to Chef. We'd also build AMIs, and the updates, we'll explain this a little bit, but the updates to Chef and the AMIs end up diverging a little bit, because there's the question of how immutable do you want to be, right? We like immutability because we like not having problems in production.
But, so then we started using Jenkins to just build a whole bunch of golden images, and then we had a lot of golden images.
We had a lot of golden images.
Way too many.
And They're really great, actually. I mean, they're sort of a pain because you have to build them, and each one takes about 20 minutes to build. But it's like I can do anything to Chef and not worry about affecting production, right? This is 100% immutable, right? Then this happened, which was a few weeks ago, where DynamoDB ran into some problems, and we started seeing some of our microservices have problems.
Is this a graph of like response times, amount of screams per second, like?
Yeah, they're 500 errors, but it's sort of complicated. So it affected one of our microservices, but it had sort of a cascading problem. But
and you couldn't recover super quickly because of
so what we found, right? So
not running Chef client.
Exactly. So what we found was we needed to patch the application to not be able to talk to Dynamo. That was that was the immediate need. And with Docker is great because you could go and you could make the change to the application and then push that change up and change the container. Mm-hmm. But how cool would it be if you could just change an environment variable using Chef and then restart the service? Yeah. So this is where we've...
Is this the Amazon is broken dial?
Yeah, exactly. That is exactly the dial, yeah. And so, we started talking about how immutable we wanted to be and what things we wanted to consider as acceptable for Chef to control.
And this is, that's kind of where when I left, we were starting to look at what were the next steps going to be, for container orchestration, because obviously most of the solutions out there, be it, Kubernetes, Mesos, whatever, don't really do auto-scaling the exact same way. There's service discovery implications that you have to consider, more networking to think about. I mean, right now, Drama Fever has a pretty simple and really solid platform. So we have to, we were thinking like, okay, we have to be careful about, of course, we want better resource utilization. And we want the ability to handle spikes like with the notification service. Sometimes people really want to know when the new episode of their favorite K-drama comes out, and so they subscribe and they want a notification on their mobile phone like immediately. But that means that sometimes there's huge spikes in the notifications that then go away really quickly, so fast that you're not going to spin up EC2 instances. But maybe if you had a heterogeneous container fleet, you could spin up containers fast enough.
Yeah, I mean, there's a lot of reasons why we would like to move to being able to auto-scale by containers rather than instances. Resource utilization could be better, which would hopefully bring down the EC2 costs. And, of course, it's faster, right? I mean, you can bring up a container in, less than a second in some cases. And bringing up a new instance can take 3 minutes, 6 minutes, right?
Plus conference-driven development. I mean, what do you want to talk about next year?
Kubernetes.
All right.
But complexity is a real concern because, as Bridget stated earlier, the system we have right now is pretty it's pretty easy to understand.
And it actually works. And, crucially, when you're running Docker in production and have actual customers who are paying you, they would like it to keep working.
Yes.
And they don't really care if you get to play with Kubernetes or not. So I thought it would be kind of fun to put up the pizza as a service slide that we've all seen a million times, just to kind of talk about like where Drama Fever is using stuff in this.
Yeah, and this was the first time I had ever actually seen this. I don't know why. I probably should have seen it earlier somewhere. But when I started thinking about it, I think Drama Fever probably sits somewhere between take and bake and pizza delivered. We've built our own platform, but we consume a lot of AWS services. So, most of a great deal of things are handled for us.
Like state, which is always a pain with containers.
Like state, like queues, caching.
Yeah. And if you didn't see my new boss, Andrew Clay Schaefer, tweet this one really cracked me up because there's a lot of talk lately about like structured versus unstructured platforms, opinionated or unopinionated, which basically come out to the same thing. Structure and opinion, pretty much the same thing. And at Pivotal, we have a platform as a service, open source Cloud Foundry, which is very opinionated. And Andrew liked to kind of compare that to opinionated tree houses, look like the one on the left, And unopinionated tree houses, they look like a pile of 2x4s. And then he had a really funny discussion with Kelsey Hightower where Kelsey said, no, Kubernetes is more like 10 different ladders. And I'm like, you're making his point for him, Kelsey. So it really, when you're trying to solve this problem and it's 4 years ago and you're Tim and then Paul joining Drama Fever and trying to decide there isn't something out there that does what we need, we should build something, then this actually is a pretty good way to go. If it's 2015 and you're starting from scratch, if you decide to do what Drama Fever has now, we can tell you it'll be pretty solid. It'll probably work. It may not scale to everything that you want. And so I think it's super important when you're choosing the platform for your developers to ship their applications on, or if you're a developer and you would very much like a great platform to ship your applications to have it run on, it's super important to think about what are you going to build, how are you going to maintain it. We didn't even get into monitoring, logging, like a lot of that stuff, spoiler alert, as long as you're fine with mounting a var log from your containers back out to your host instances, you're fine. It's just like everything before. But I think it's important when you're thinking about this stuff to consider exactly what you should build, what you should look at that's in open source projects out there, and like what the right balance for your organization is.
Right.
So yeah. I think we're contractually obligated to say that our organizations are hiring. Isn't that right?
I think so.
It's like, I don't know. Final words. What do you think? Docker? Should people Docker?
I think people should use Docker, definitely. And not just because it's trendy, but I think people should use Docker because it solves a lot of really annoying pain points, dependencies being a huge one, and being able to replicate,
versioned repeatable deployment artifacts.
Yeah, and it's great from an ops perspective. It's great because we can form a contract with our developers by saying like your images need to do X, Y, and Z, right? Like they need to log this way, they need to be able to provide metrics this way, and then they've provided something that is essentially like each service is exactly the same, right? So it doesn't matter It doesn't matter if it's our web application or it's one of the Go microservices. Each one of those things, should follow that contract, and then we can apply that template in production.
Yeah, and basically, I think if you're not using containers yet, you probably will be soon. Whether or not you know it, depending on what kind of underlying infrastructure you're buying into, everything is going to containerized platforms of one sort or another. So
yeah, the landscape's moving in that direction. Totally.
It's a good idea to take a look at. Yeah, and we have 2 minutes left. So if we have any questions / heckling, I'm looking at the people in the heckling zone who are mouthing Docker, Docker, Docker at me. Andy.
Looking at application orchestration, does that challenge or concern you from a security perspective, like the way you're maybe not sprinkling the same containers across the same EC2 instances together?
I mean, I think that's a valid concern because it's super easy when you know exactly where your containers are going to be launched to set your security group such that something can only talk to, say, the data store it's supposed to. And if you're going to have a more heterogeneous fleet of instances that you can run any container on, then any of those things need to have ability to talk to whether it's their Memcache or their Redis or their backend data store of some sort. So yes, you can't be quite as locked down. Is that a problem or not? I guess that depends on how much what does the Conway's law in your organization look like? How much do you trust the different parts of your organization? What do you think?
Yeah, I mean, of course, there's always security concerns in that respect, but I think as far as
you could get threat stack. That would solve it.
Yeah, I mean, I think as far as where we're at right now with orchestration, it's an acceptable risk because for the most part everything is pretty well locked down, right? And yeah, I mean, when you're in the AWS space, if you're using security groups, IAM policies, if you're using all this stuff appropriately, you should be fine.
I think the answer that you were looking for is it's probably fine. OSPA.
How long does a full production deployed?
That's a really good question. So it depends on the service.
We should repeat the question, which is, how long does a full production deploy take?
So it depends on our service. Now, if we're talking about just the application itself, that can be very quick. So like our microservices, because you saw they're 10 megabyte containers, images rather, that whole, we could deploy that entire thing in probably 5 to 10 minutes.
With the Django application, because that you saw the images are almost a gig, and a Docker pull has to happen to each EC2 instance, Tim did actually parallelize it so that you can set however many instances you want to pull out of the load balancer at a time. So some of that actually does depend on how busy the site is. So I would recommend not doing your deploys while everyone is watching their favorite TV shows at 9 o'clock on a Friday night. I mean, unless it's an emergency.
Yeah, and because the way we do our orchestration, where instances are pulled out of the ELB, and then they're restarted and then put back in the ELB.
The more instances that happen to have scaled up at that time, the longer it will take.
So the deploy time, are they're not proportional to the size of the change?
No, the deploy time has very little to do with the size of the change because of the way that the instances themselves for the web services at least get pulled out of the load balancer.
Yeah, the time for our deploys would correlate with the number of instances and the size of the image. Right. So yeah, I mean, and the truth is the size of the image doesn't always. It depends on what happens. So if a dependency is changed, if the base, like we showed earlier, if the base image is changed, it's going to take longer because what that'll do is that'll affect layers that are high, I don't know, higher or lower up in the Docker stack, right? Because the image itself is a series of layers. So if you end up changing one of like the base layers, then it ends up sort of like needing to download a whole lot more. But if you're just changing, like making a simple change to the application, that image pull is probably just going to pull the last layer, and it's going to be real fast. It'll be like maybe a, I don't know, 20 meg, 50 meg pull.
But if you're only going to change about 3 lines.
Yeah, so it doesn't.
Yeah, it should be quick. But again,
but like 3 lines of change versus 100 lines of change, or 1,000 lines of change. It's going to be the same time.
Correct. The number of lines of change does not affect how long the deploy takes. It may affect how long the build takes, I guess. I mean, all the tests and everything, but I mean, it has to run all the tests regardless. So.
Yeah, I mean, if you're talking full end to end, those numbers there's different. There's a lot of other stuff that happens in there. Truthfully, to do a full release for say like Drama Fever. If everything goes swimmingly,
I'd say
it'll probably take 45 minutes to an hour. If you run into issues, it can take much longer than that. And we definitely, it's a goal of ours to get that down as much as possible.
Yeah, I think we're just about out of time unless we have a question in the back, so we'll answer one more question. Yes. I'm sorry, I can't hear you. Yeah. How does Drama Fever handle blue-green deployments? I'd say with this particular process, Drama Fever is not using, at least when I left, we're not using blue-green deployments as such.
No, we're not using blue-green deployments, but
it's possible just by because of the way the deployment works with pulling instances out of the load balancer. We had gone down a path of starting to look at either spinning up another auto-scaling group. Or just, we do like probably the smoke testing kind of in the staging environment is the closest in that if it's successful, like there is one instance, kind of a canary release, there is one instance in production that is on the new code base. And then schema migrations occur and, are hopefully completely forward and backward compatible. And sometimes not with hilarious results.
Yeah, and this is different than that form of deployment, but what you can also get with Docker, which is nice, is that, say you have a QA image and you're ready to send it out to prod, you can tag it as prod, right? But what's even better is before you do that, you take the old prod image, right? and you tag
Like it
that.
is whatever you like.
Yeah, and you tag that as like rollback, right? Or something like that, or pre-prod, whatever you want. And so if for some reason when you do roll out to prod, there is a problem and you need to roll back, it's a trivial thing to do because all you have to do is retag your rollback as prod and run through your orchestration real quick that that restarts the service.
But
And
I think the blue-green deployment thing, though, is definitely on the roadmap, and that is more related to the Amazon load, ELBs and auto-scaling groups than it is to Docker. Like, I mean, we did blue-green deployments at a previous gig where I wasn't using Docker, but was using AWS, and it would essentially be the very similar process here.
And this is, again, just like doing preliminary research and talking to people, but it seems like Kubernetes can offer that as well with the way they do some of their namespacing.
Kubernetes, Mesos and Marathon, Cloud Foundry, like all of those can do that. It's just a question of, for all of those, again, the auto-scaling piece is very different. And so that's kind of the research right now is figuring out what the right path is. So yeah, well, I think we're way out of time and I think everybody wants to go to the reception. So thank you so much for hanging in there with us.
Yeah, thank you.
It's been great. Thanks.